Now, these are the properties that we have for enlargement and reduction transformation. Okay, so you guys need to take a screenshot of this because I feel like it's a lot of notes to try and write. I think you guys will be much safer. I believe you can, Zianda. I believe you can still pay for the boot camp because it's not this week, it's the next week. It's not even the next week, it's that week. Yes, I believe you can, Zianda. Please just message the WhatsApp contact you have for customer experience and they should be able to help you, okay? Yeah, I believe you can still pay for the bootcamp. Okay, all right. Now, let's look at our properties, okay? So these are the properties that we have found. Now, all the sides have to be scaled to the same proportion, okay? And this proportion, we will call it the scale factor of the transformation. So what it means is we need to increase or decrease all sides in the same proportion so that we maintain the same shape. Remember, we're not creating new shapes here. We are just enlarging or reducing the same shape. Okay. Second one says, for enlargement and reduction transformation, we must specify the center of enlargement or reduction. But as we've seen, we haven't used that specifying the center much, right? Because we are not actually drawing. That is usually for when you are drawing, physically drawing using Cartesian plane and rulers and all of that. We're going to focus more on the rules, the numerical rules. Okay. And then for enlargement, this is important rule number 1. For enlargement, the scale factor will be greater than 1. Okay. And for reduction, the scale factor will be between 0 and 1, which means what? It is a fraction, right? So for reduction, the scale factor will be a fraction between 0 and 1. Okay. Now, the perimeter of the image will be the same as the scale factor. We haven't done perimeter yet. Okay, it's our next section, this part. I'll bring back when we're doing area and perimeter and see how enlarged and reduced shapes relate to one another. So these two we'll deal with when we are doing perimeter and area. And then the shapes are similar. Remember when we spoke about reflection, rotation, and translation? The shapes were congruent. Do you guys remember that? Because it was just the exact same shape that we moved. This time they will not be the exact same shape. Why not, guys? Why can they not be congruent anymore? Why can they not be congruent? Yes, Mikhail?
The reason why they can't be congruent is because they'll be the same shape, but they're not going to be the same size because we're enlarging it or reducing it.
Thank you very much, Michaela. And that is exactly correct. That's the answer I was looking for. So Michaela said it so nicely for us. Okay. They are not the same size. Thank you, Andy Zwa and Zeketela. I see you said the same thing. So they cannot be congruent because congruent means they are the exact same shape. But in this case, they are not the exact same shape. Okay. They are enlarged or reduced. And we have a nice little picture here that shows us the difference between the two. As you can see, this car looks the same in both pictures, but reduction means you make it smaller. Okay, so reduce means you make smaller. So that's why it's the left to right arrow. So you're going from the bigger one to the smaller one. And enlarge means make a bigger. See. Okay, so I'm going to go up and I am going to let you guys take screenshots before we continue. Do you guys have any questions about what's on the screen right now? The two that I really need you to remember are these ones. Let me highlight them nicely. If you are enlarging, then your scale factor is anything greater than 1. But if your scale factor is between 0 and 1, meaning it's a fraction, then the scale factor, nope, then it is a reduction. There we go. There we go. There we go. You're going to need to remember this in like 1 second. Okay. Hi, Chi-Chi. Now, let's look at this, guys. We just spoke about scale factor. Remember, for transformations, we have been writing the change using the original coordinates. Okay, so let's say I know, but I was highlighting it nicely. Sia, don't hate on me. The first time looked like, I don't know, I was using my foot to highlight it. Okay, so let's say the original one was X, Y, and I say our scale factor is K, which is what they did over here. Okay, so they're telling us K is the scale factor. Guys, why did they use K? They only used K as a placeholder, right? They use K as a placeholder. It's just a variable that represents a possible number. So if your scale factor is K, what you do is you multiply both coordinates by your scale factor. So that's where the KX and KY comes from. Now let's check if we had a scale factor of a number. So if I say to you, my scale factor is 5. Let me go to the side here so we can practice what I'm talking about. Okay, my scale factor is 5. So then instead of being XY, my new coordinates will be what? 5x, because you're multiplying, and 5y. Do we understand that part? Let me check in. I saw a hand go up. Is it a question? Oh, it's gone. Yes. So you have to multiply both coordinates with the scale factor to find the new coordinates. Okay. Do you guys want to do a few examples using actual numbers? Do you want to use, is it possible for it to become negative? No. No, it won't be negative. Okay, it's either between 0 and 1 or greater than 1. I'll show you why just now. Okay, I will show you exactly why it can't be negative. That was, yes. Yeah, you guys need to listen, okay? Remember, stop greeting each other in the chat. We're in the lesson now. Listen carefully, okay? I said, when you are given a scale factor, okay, that's going to tell you how much you increase your shape by. So if I say to you, my scale factor is 2. That means I have increased my shape 2 times, okay? I have doubled the size of my shape. So if my original coordinates of my shape were, let's say coordinate number 1 was 2, 3, and this one was 7, 4, then my new coordinates, you have to multiply this 2 with every single coordinate to get your new coordinates. So then you're going to say, it's the 2 that was already there, times the 2 that's your scale factor, and then the 3 that was already there, times 2 that's your scale factor. So what's my new coordinate? So your new coordinate is what? 4, 6. Thank you very much, Andiswa. This is my coordinates for my new shape. So then for the second one, what will my new coordinates be? Let's see. Thank you. See, you guys are getting it. You will multiply every single coordinate by your scale factor. This makes 14, 8. Nice, guys. Are we feeling a little better about what I said? So when you're given a scale factor, you will multiply your coordinate by that scale factor. Nice. Yes, Chi-Chi, do you have a question?
Hi, ma'am.
Hello.
I also have a question since I since I arrived late. So I just wanted to ask, since we found our coordinates, we have to like put them in brackets and then times them with the scale factor.
You don't have to do it. I'm just doing it to show you where I'm getting my new coordinates from.
Okay.
Because if I
But will
just
they
write
give us
3, 4, 6, then you'll have no idea where that 4, 6 comes from. So I'm just doing this to show you that I have multiplied all my coordinates by 2 in order to get the new coordinates.
so like what if they give us this exact same thing in an exam? Will they just give us a random number? Or like this is like an easier way to find the next coordinates?
Yes, this is the only way to find the next coordinates with enlargements and reductions. Okay, you
Okay.
always multiply by the scale factor, always.
Okay, ma'am.
Here we go. Okay, guys, so we always multiply by the scale factor. So for those who are confused, that's exactly what I was doing here. This time I just wrote K because that's what they usually use to represent the scale factor because we don't know what it is. So just as we don't know what X and Y are, right? We're using variables to represent numbers. We used K. All right. If you are reducing, Kanyo, then you will have a fraction. Your scale factor will be a fraction. Let me show you. Let me show you. So if you're reducing, let me show you your scale factor. Yes, there we go, Bridget. Let's say it's a half. Okay, let's see, so scale factor is a half. And then my original coordinates are 8, 6. And let's go with 12 and 2. What happens if you multiply stuff by a half, guys? Does anyone know? So you do the same thing. So you're going to say 8 times a half. What happens if you multiply stuff by a half? Yes, Mikhail?
It's divided by 2, ma'am.
Thank you, Mikhail. It's divided by 2. So then my new coordinates will be what? Oh, she vanished. What are my new coordinates, guys? 4 and 3. So do you see what I meant, guys? When your scale factor is between 0 and 1, do you agree that a half is between 0 and 1? So K is between 0 and 1. So it's a fraction. Then it is a reduction. But if your scale factor is greater than 1, then it is an enlargement. Are we with me, guys? Do we get what we mean? So it will not, your scale factor will not be negative, okay? It's either between 0 and 1 or greater than 1. Let me finish this one off quickly. So new coordinates, thank you. I see you in the chat, 6 and 1, and I wrote that one very terribly. Let me do this. Okay, are we with me? Thumbs up, thumbs down of how we use a scale factor. Okay, I see thumbs up. And the reactions for all the new people, when I say thumbs up, thumbs down, please go to reactions, press reactions and press a thumbs up or a thumbs down if you do not understand. All right, so far the pieces of information. So enlargement is just multiply by 2. Then to lower it's half it by the before digit. Just multiply by the scale factor. That's all you have to do. You're going to be given a scale factor and you multiply by that scale factor. Okay. Okay, it seems like we're okay. I think we should do a few examples with the scale factor being given to us before we have to figure out the scale factor. Okay, here we have to figure out the scale factor. Oof, and this one. And here. Okay, Triangle ABC is enlarged by a scale factor of 3. Let us figure out what the new coordinates are, and you guys are going to help me. But first, I'm going to plot the original triangle. Okay, so let's plot to ABC. It's 2 and 3, which is over there. I don't like using black because you can't tell the difference between where I wrote. Okay, 2 and 3 is over there. The next one is -6 and 3. So it's over there. And my last one is 5 and -2. Nope, that's 6 and -2. Hey guys, I can't see. 5 and -2. These lines are very confusing, but it's fine. There's my triangle. Let me draw it. Now you guys are going to tell me, how are we going to find the new coordinates? We should know by now, we just did it. How do we find the new coordinates? Yes, Mikhail. Mikhail's on fire today and I am loving it. Yes, Mikhail.
We're gonna multiply them by the scale factor, which is 7.
We're going to multiply them by the scale factor, which is?
3.
Nice. So then what's the new coordinate for A?
6 and 9.
Okay, let's call it A prime will now be 6, 9, and then B prime?
-18 and 9.
And 9, and C prime?
15 and -6.
Nice, Mikhail. I love it. Okay, guys. I just realized my new triangle isn't even gonna fit on my freaking coordinate points, okay? Because we can plot 6 and 9. That we can do. 6 and 9 goes over there. Right? But then we have -18, which doesn't even exist on here, and yeah. Okay, so this is for scale factor of 3. I'm gonna plot for scale factor of 2. So let's see. Scale of 3. Now I'm gonna make another one and say scale factor of 2 so that we can see the difference between the two. It's good if your teacher taught you this because that means we are on the same place, right? If I use a scale factor of 2, A prime prime will be 4 and 6. That looks a bit better. B will be -12 and 6. Yes. And C will be 10 and -4. That looks a little bit better. There's only one point that might not fit, but I can make a plan. Okay. Wadey, how did you guys do this 2 terms ago? Your teacher is roping us. But it's good. It's good. Now we are refreshing because you guys are going to write about this in your exams. Okay, so my scale factor of 2 triangle. For that, -12 can't fit, but we can force it. It's -12 and 6. So it's here somewhere. It's about there. And the last one is 10 and -4, which is all the way down here. So since we were doing an enlargement, we expect the triangle to be what? Bigger or smaller than the first one? We expect our triangle to be what? There we go. Do we see that it's virtually the same triangle, just bigger? There we go. And do you see that it is exactly the same triangle, just bigger than the first one? Do you see how we transform shapes now? So if you're given a scale factor, you multiply all the coordinates by that scale factor, and then you plot your new shape, and it should look like the first one, just either bigger or smaller, depending on whether you were supposed to enlarge or reduce it. Do you guys have something to say in the chat? What's going on? Thumbs up, thumbs down. How are we feeling? Yes, Oratile?
Hi, ma'am.
Hello.
So, ma'am, sorry. So, ma'am, when we reducing, ma'am, do we make it like, do we divide?
No, we always times, Oratile. You saw what happened when you times with a fraction, right?
Oh, ma'am, I'll have to.
You have to?
I'll have to look at it again at the recording, ma'am.
Okay. Well, you know what? We're going to do one right now with a reduction. But
Okay.
let's do this quickly, Oratile. Okay. Let's say my scale factor is a third. Okay. So I'm giving you a scale factor of a third. Are you with me?
Yes, ma'am.
Oratile, if my coordinate was 3, 9, and I am multiplying by a third, use your calculator and tell me what my new coordinate is.
Ma'am, 1, ma'am.
1 and
9 and 1 and 3, ma'am.
you see that it's reducing.
Oh.
So still multiply. Okay.
Okay. Thank you so
Never-
much, ma'am.
You're welcome. So we never divide, guys. Just remember that we always multiply. But if it's a reduction, it will be a fraction. Now, I have a question for you guys. Let's say we're given shapes like so. Okay? We're given shapes and they ask us, are the following shapes, well, a reduction or enlargement? That you can just look at it. But now they're asking you for a scale factor. Determine the scale factor. So the first one we were doing, we were given the scale factor, right? Now they're asking you to find the scale factor. Okay, now you guys are going to listen to me. What you're going to do is you always take the new triangle. Okay, between these two that we have here, which one is the original one? Is it the gray one or the lime green one? Which one was the original one? Thank you very much. It was the gray one. Okay, so you're always going to put the sides of the gray one at the bottom. All right, so triangle, the new one will be W, X, Y will be at the top, divided by triangle, the original one, which is WXY. Now, for you to find the scale factor, you need to find the scale for all the sides. Let me show you what I mean. Okay, so you're going to say WX, which side is that? It's this side over here. You guys see it? I'm comparing these two sides. Are we with me? So we're going to say the new WX over the old WX. Tell me, how many units is the new WX? This one, the lime green one. Oh, Wadey said Y. Wadey, remember the ones with the primes? This one? Those are the new ones. Okay, the original one has to be the gray one because it didn't have the prime. Buhle says it is 3 units. Ma'am, do we have to find the coordinates? Yes, Chichi, you do have to find the coordinates. Let's find the all ones, guys. How long is this side, WX? So it goes from where? From 10 to 4. So how long is the side, guys? Bigger minus smaller? Thank you very much. We're below. So that side is 10 minus 4 units, which is 6. You could have just counted, but if you want a method, you always say the bigger coordinate minus the smaller one. So it is 10 minus 4. And now let's go to the gray one. Let's go to the gray one. How long is WX, the original WX, guys? Oh, Setabile already knows the scale factor. What is it, Setabile? Give us a hint. It is 2 because it is 4 minus 2. So this is going to give us 6 over 2, which means is equal to what? Yes, Chi-Chi?
Hi, ma'am.
Hello.
I just want to ask a question real quick. So, like,
Mhm.
if we want to find how big it is, like, we have to count how many blocks it took to, like, get the enlargement. Like, the green one, I counted the blocks. Like I said, 1, 2, 3, 4, 5, 6. It ended to 6, and we got the answer 6 from the 10 minus 4. And then,
That's
like, the second
fine.
goes.
But remember, if you don't have blocks, you should still be able to visualize it, right? If the shape
Yeah.
starts at 4 and goes up to 10, then you just know that it took 6 blocks. You get it?
Okay. Yes, ma'am.
There we go. Okay, Mikhail. Yes, Mikhail?
Ma'am, when the method I saw doing, ma'am, is that I looked at the original like coordinates. So x was 2, and then in the bigger one x was 4. And then when you do it with all of them, can you just divide it like that instead of counting the blocks?
Yes, but remember that's what I did here. Do you see I said 4 minus 2?
Yes, ma'am.
Yes, because I went 4, which is the coordinate for W, do you agree? Minus 2, which is the coordinate for X. That's why I got the 4 minus 2.
Okay, ma'am.
Here we go. Okay. Okay, Setabile.
Ma'am, the method that I used, I also counted the blocks, and I realized that on this side it is 2 blocks, and then here it's 6 blocks, and then you just divide and then you get 3. So
Yeah, that's fine also. But remember, you need to know if you get a Cartesian plane with just coordinates, or let's say you don't get a sketch, you do know it's possible that we're just going to give you coordinates, right? So then we say to you, let's say X, the coordinates are 4, 7, and for Y, the coordinates are 2, 9. You need to be able to do it with this method, even if you don't have a sketch. Okay?
yes, ma'am.
Yeah. Okay, and as Setabile has just told us quickly, it's 3. But you have to go through this with all the sides, guys. Why do you have to go through it with all the sides? Does anybody know why?
Just to
Anyone?
make sure.
Just to make sure. Thank you, Setabile. Because it's possible that these two sides are 3 units, and then suddenly your hypotenuse is like 7 units or something. Then is it the same shape? It's no longer the same shape, right? It's not similar anymore. Remember, one of the conditions of similarity was the sides are in proportion. Do you remember that? So if the sides are not all in proportion, this shape will no longer be a similar triangle. Okay. Is it 6 because you said 6 divided by 2? 6 over 2 and 6 divided by 2 are the same. Okay. So we did divide by 2. So let's do the other two sides just to make sure. Okay. X prime, Y prime over the original X, Y is, how long is X prime, Y prime? It's this one over here. How long is that shape? Yes, Setabile? Oh, Setabile's hand just went down. How long is X prime, Y prime? 6. Let's see. 1, 2, 3, 4, 5. So 6. So however way you do it, it's fine. And then how long is X, Y? 2. And that gives us what? 3. Now we have a problem with this one. How long is that one? What can we use to find the length of the third side accurately without guessing? What can we use to find the length of the third side, guys? Anyone? This is a triangle, right? So what can we use to find the length of the third side? We all forgot our previous rules. Yes, Mikhail?
Pythagoras, ma'am.
There we go. We can use Pythagoras because we know the lengths of the other two sides, right? So for the small one, it's wx squared plus xy squared equals wy squared. Now we know wx and xy, right? Wx is 2 and xy is also 2. So 4 plus 4 equals wy squared. Therefore, square root of 8. Wonderful. And now, you guys are scared of missing accurate plus x prime y prime squared. Why did I say you have to use Pythagoras, guys? Does anybody know why? Why did I specifically say that accurate sentence? Why did I have to specify that? Is it safe for us to just assume? Thank you, Mikhail. Remember, it doesn't mean necessarily that these triangles are drawn to scale. So you can't just assume that they are certain size, right? W prime, y prime squared is equals 36 plus 36, 72. Therefore, y prime equals the square root of 72. Whew. Now we do the same thing. What is y prime? Nope, w prime y prime over wy, which means the square root of 8 over the square root of 72. How much is that? Calculator? Yes, it only works for right angle triangle. Yebo, I saw hands go up. Oratile, yes, Oratile.
Hi, ma'am. I'm sorry, ma'am. My network was bad, ma'am. How did you get 36, ma'am?
What's 6 squared? Remember the lengths of the two sides was 6, remember? This was 6.
Oh,
That was 6, and so was that. So I
okay,
said the lengths. So it was 6 squared plus 6 squared. Okay,
okay. Thank you, ma'am.
you're welcome. That was a good question. Yes, Chichi?
Ma'am, the answer for that is 1/3.
1/3.
Yeah.
Did I do it the right way around? It's supposed to be 3.
I did it on the calculator. It says 1/3.
Oh, it's the other way around, Chichi. It's the other way around.
Okay, then.
The prime is the longer side. It's the 72.
Okay, so
Over that, so it is 3.
yep.
There we go. Whew. Guys, remember, substitute correctly. I wrote it correctly here because I said w prime, y prime. That's this one, which was root 72. So it's the square root of 72 divided by square root of 8, and that gives you a 3. Now we got 3 times. So then we can conclude that our scale factor is what? Our scale factor is what? 3. Does that make sense? This shape has been enlarged, right? So we did expect a scale factor greater than 1. Do you see, guys? We did expect a scale factor greater than 1. So you guys need to check your answers. Do you now see the difference between using a scale factor to enlarge or reduce shapes and then finding a scale factor? Let me check in, thumbs up, thumbs down. I know this one was a little bit messy. We might have to do another one, but how are we feeling so far about finding the scale factor? So we have now covered using the scale factor, and then we did the finding the scale factor. Okay. Okay, I see thumbs up. Is anyone with a thumbs down so I can help you quickly? There we go, Tando. Where did I lose you? Where did I lose you, Tando? Raise your hand and just let me explain to you quick. Don't be shy. It seems like everyone is sort of getting there. Yes, Tando.
Hello, ma'am.
Hello, Tando.
So ma'am, I want to find out something. Why did we exactly have to use Pythagoras? So from the part where we have to find the hypotenuse side, that one I understand. But like when it comes to where you do this the solution, I'm sort of confused. Where did we get the 4 from?
Which 4? Oh, this one.
So yes, ma'am. From 4
Coordinate.
plus 4 equals y, wy squared.
Oh, how long were the lengths of WX? How long is WX? Look
Is
here.
it 2
Yes.
for
So
prime or the original?
for the original. They
For
were
the original,
2.
it's 2, ma'am.
So what's 2 squared?
2 squared is 4, ma'am.
Do you see where I got those 4s?
Wait. Ah,
There we go.
okay, ma'am.
I did
Thank
the same
you.
thing here. Remember, I didn't write 6 squared plus 6 squared, but W prime X prime, the big one, the sides were 6 units long. So here, before the step, is 6 squared plus 6 squared. That's where the 36s come from. You see?
Okay, ma'am.
Hey, are you good?
Yes, ma'am.
Wonderful. Okay, screenshot people. Are we done? I think it's time we go to a brain break before we find one more scale factor before we end this lesson. Everyone was taking a screenshot. I hope you all are great. And Chichi is having the time of her life there with little emojis. They're adorable. Okay, let's move on. Let's have a little brain break, and then we're going to find maybe 1 or 2 scale factors, and then we can head home. We're going to do this one next, where we're coming, and then this one, and then we'll be done. Nice. Let's see hands. Let's see hands for the would you rather. There we go. Setabile, you ready?
Yes, ma'am.
Okay. Would you rather have bright purple hair or purple teeth?
Bright purple hair.
You would rather have bright purple hair.
Yes.
So you don't care about your outfits, Setabile. Imagine having bright purple hair, wearing a yellow dress.
Ma'am, imagine smiling and your teeth are purple.
Just don't
Just
smile.
imagine.
Just don't smile, guys.
Ma'am, just don't smile. No, ma'am, I like smiling. So, purple hair.
Guys, imagine you guys who haven't combed your hair in forever. I know there are some few of you in here. Imagine that hair was purple. Oh my gosh. Okay, so it seems like everyone's agreeing with you with the bright purple hair. That's fine.
Ma'am, do you disagree?
Hey, you know me, I just put these questions. I don't answer them.
Okay.
I'm dropping stuff. I just put these questions, guys. They're too difficult for myself to answer also. Let's hear. Chichi, are you next for are you ready for your question?
Yes, sir. Yes, sir.
Chichi, would you rather only go to school in summer or in winter? Only in summer or only in winter?
Winter. Ish, but winter would be nice though, you see. In winter.
Winter at
stay at
home would
home.
be nice, guys. In bed, imagine.
Yeah, but school. Ish, but school. Going to school in the cold. You're wearing a skirt and it's cold. Your classmates refuse to close the door.
So you'd rather go in summer?
Ish, but also summer, ma'am, it's bad because it's hot.
Chichi has problems.
Ooh. I think I would choose winter because like what if it's winter and then like it starts snowing at school, Yana, it's gonna be fun. I'll be throwing people with snowballs, you see.
Oh no, that sounds like yesterday. Guys, people went crazy like they've never seen hail before in Joburg.
Ma'am, you
Like,
know why?
and everyone was
No, I'm
outside and they were throwing some guys. I was like, guys, it's just
Ma'am,
hail, ice. You
but ma'am, you know why? I would rather choose winter because I wasn't able to see for like the snow day. I wasn't here during like when it was snowing. I never got a chance to see
right.
the snow for the first time. So I'm still angry about that. But winter is, you see.
Okay, guys, Chichi's going with winter. And I would go with summer. I'm not even gonna lie. I hate getting cold. Umolemo, you ready for your question?
Yeah, ma'am. Can you hear me?
Yes, I can. Would you rather have an
Okay.
unlimited gift card for McDonald's, or I wasn't even done typing my or what? The cinema. There we go. Unlimited gift card. McDonald's or movie. Unlimited.
To be honest, probably a gift card for
No,
multiple
but you have
reasons.
gift cards from both. So you either get one from the cinema to go to the movies every day, forever and ever, or one from McDonald's. Hey, look at these people with food. Even you, Mr.
Cinema,
Moon.
ma'am.
Thank
Cinema,
you very
ma'am.
much.
Come on.
Cinema.
It's
Cinema. Oh my goodness.
um,
Because guys, you can go
McDonald's is so unhealthy, ma'am.
and you can go watch movies with snacks every single day and not pay anything. Guys,
Exactly, ma'am.
these people are not focused. Do you see how quickly Miss Simone answered that? Like she didn't even hesitate. Yeah, I get. No,
We
Voya.
eat every day, Miss Cat. We eat every day. Movies are once in a
Exactly.
while.
So go to the movies now and then. Yo, you guys wanna eat every day all day forever. I mean, guys. You, awa. Mm-mm. You. No, Voya, are you ready? Last question.
Hello, ma'am.
I know, Voya. Would you rather have a huge pimple or a massive booger in your school photo? You know those ones that they print. What is that pimple?
Yeah,
It's like,
pimple.
yeah.
Oh,
I
ma'am,
think
a
it's
pimple is
like
fine.
it's a tissue. Like what? Okay, I'm done. I'm done trolling you guys.
But then, ma'am, you're taking a photo for school. Then
Yeah,
there's a huge booger
yes. You're
showing
trying to just be like,
on
just
that school
friend, just
photo. Yeah, I think I'm fine with a pimple.
see, I was like, no, both of them are giving me heartburn. I don't want any of them. I'm done. Okay, guys. Okay, let's go back to the lesson. Let's go back to the lesson. They are terrible, Umulema. Even as a teacher, I hate school photos. I saw mine this year and I was like, what is that? I'm convinced it's sabotage, those pictures. It's sabotage. Okay. You can be known as Boogie. You guys have post-traumatic stress. What's going on in the chat? Okay, guys. So we have our two shapes over here. All right. This is a square this time. And it has obviously been enlarged because you can see that the smaller shape is the original. Okay, now we need to find our scale factor. Maybe I should first write down the coordinates. X, okay, W. Okay, if my handwriting can cooperate, that would be lovely. W, X, Y, and Z. My coordinates for W Let's hear. Coordinates for W. Yes, Sia.
Hello, ma'am.
Hello.
Can I help you find the coordinates for the small one?
Go for it.
So the coordinates for W is -3 and -3.
Nice.
For X, it's -1 and -3.
Thank you.
For Y, it's -1 and -1.
Last one.
And Z is -3 and -1.
Thank you very much, Sia. Okay, let's see. Setabile's hand just went up. Yes, Setabile.
Ma'am, I would like to help you with enlarged one, ma'am.
Okay, let me write this. W prime, X prime, Y prime, and Z prime. Okay, let's get started. W prime, coordinates.
W prime is -12 and -12.
Next.
X is -4 and -12.
12, okay.
Y is -4 and -4.
And the last one.
And Z is -12 and -4.
Nice, guys. I saw some people say they already have the scale factor. Say Tabile. Was that you? Yes, it was. What's my scale
Yes.
factor, Tabile? How did you get it?
Ma'am, I think the scale factor is 4.
It is. What you can do is, remember, to use a scale factor, we multiplied, right? So you can go
Yes.
backwards. We can say -12, and you divide it by -3, and that gives you
-3. 4.
Oh, which is my scale factor. That was way too easy. I'm not comfortable with that. You know, guys, I want to shake life before this is too simple, but it's fine. Our scale factor is 4, and you can test it by multiplying all the coordinates by 4, and you will see that that is indeed correct. So for the people who are asking, why can't the scale factor be negative? Do you see that we are working with our lengths? Okay, so in the previous one, we said what? We said the primes. So let's say I say W prime over X, no, WX prime over WX. What's the length of W prime X prime? It's -12, right? Nope, not -12, excuse me. Not -12. It is 1, 2, 3, 4, 5, 6, 7, 8. 8 over 2, which is 4. So we can't have negative lengths, guys. Okay, we can't have negative lengths. So that's why. So these are the two ways you could have found the scale factor. Were you guys able to find the scale factor? Thumbs up, thumbs down. Where's the... How did we get -12 divided by -4? So Buhle, remember I said if you have a scale factor, right, you multiply to get the new one. So let's say you had -3, -3, and you got to -12, -12. You need to figure out, how did I get from -3 to -12? So what is the inverse operation of multiplication? What is the opposite operation of multiplication? Let's hear. Anyone? The inverse of multiplication is division. So we just went the opposite way. So if instead of saying -3 times something will give us -12, we said we want to know what we times. So we said -12 divided by -3. Do you see? You could even have used algebra. So you could have said -3 times something that we don't know, which is an x, has to give us -12. Now to figure out this x, you divide both sides by -3, and it will tell you that your scale factor is 4. Do you see there are many ways to find this, guys? There are many ways to find this. Are we good? Can we end our lesson here today on a nice note? Next time we are doing exam questions, so I need you guys to try this. This guy, this is where we are starting, guys. Take a screenshot, please try it. You're welcome, guys. I'll see you guys on Thursday.